All right, so I'm now going to go over the questions, some of the questions from the last assessment that you guys took. So this way you can help practice if you need it for any of these. Remember, um, or for this one, you guys all have the same questions actually. So even though it might be version A and version B, you'll just have to find the question that matches on your test. I'm going to be doing the questions from version B for this one. All right, and these are the questions I'm going to go through 1, 3, 7, 8, 9, 10, 13, 14, and I normally won't go over mastery questions, but I'm going to go over one of them from this test today. All right, so for question number one, we're asked to solve the absolute value of 2x plus 16 is equal to 8. Now remember, when we have the absolute value questions, we have that the absolute value of 8 is equal to 8, and the absolute value of negative 8 is also equal to 8. So this actually is going to create two separate equations that we need to solve. And the first one that we're going to create is 2x plus 16 is equal to a positive 8, because we know that a positive 8 will give us the absolute value of 8. Or then we would have 2x plus 16 can also be equal to negative 8, because the absolute value of negative 8 will also give us 8 as an answer. So we're going to go ahead and solve both of these questions. So we're going to subtract 16. So now we get 2x is equal to negative 8 divided by 2, and x is equal to negative 4. Or then we'll solve this one. We subtract 16. So we get 2x is equal to negative 24 divided by 2, or x is equal to negative 12. So this will be our final answer, that x is equal to negative 4 or x is equal to negative 12. All right, so the next question we're going to do here is number 3. And for this one, remember, the first thing we have to do when we're solving this is we need to simplify both sides of our equation. And one of the things I'm suggested to you, if you're struggling, is to draw a line going down that equation. Because when we're doing something just that's on one side of it, we know that that is simplifying, and we don't need to use the inverse operations if we're just simplifying. So the first thing I'm going to do is simplify this left-hand side. And remember, the parentheses mean that we need to multiply. So I'm going to distribute the 2 into both the 4x and minus 5. Well, 2 times 4x is 8x. 2 times negative 5 is minus 10. And then I have plus 1 is equal to. So now I'm going to go ahead and keep simplifying, because I see that I have two constants, negative 10 plus 1. So I will do negative 10 plus 1, which is equal to negative 9. So now I get 8x minus 9 is equal to. So now I simplified everything on the left-hand side of this equation. And remember, since I didn't move to the other side of the equation, I didn't need to use inverse operations with this. I could just combine my like terms, right? And now on this right-hand side, I'm going to distribute this 3x, or the 3 into the 2x plus 1. So 3 times 2x is 6x. 3 times 1 is 3, so plus 3, plus 2x plus 6. Right? Now, once again, I'm going to combine my like terms. Well, 6x and 2x are like terms, because they both have the exact same variable x raised to the same power. And we could do 6 plus 2 is going to give me 8, so I got 8x. And then the other one is going to be 3 and 6, and 3 plus 6 gives me 9, so I have 8x plus 9. All right, from here, you might be able to identify what the answer is going to be, but I'm going to continue to work this out. So remember, now that we have everything simplified, I need to move my variables to one side of my equation. So I'm going to move my x's to the left. Well, when I subtract 8x from both sides, I notice that they both cancel out to give me 0. Now I'm left with a statement of negative 9 is equal to positive 9. And we know that this is not a true statement. It is a false statement. So when we get a false statement, that means that it is no solution as our final answer. Right, now we're going to move on to question number 7. And this one says the absolute value of 5x is equal to negative 25. Well, we know that if we take the absolute value of positive 25, that gives me a positive 25 as my answer. And if I take the absolute value of negative 25, it also gives me 25 as my answer. So no matter what, after we take the absolute value, remember, it's always going to be positive after we take it, because we're dealing with how far away we are from 0. So since nothing will ever give us negative after we take the absolute value, this one was no solution. And there's no work that you had to do for this. You just could have right away just identified, well, it can't be equal to a negative number. Therefore, it must be no solution. All right, and now we're going to go ahead and do question number 8. We have 9 over 5 is equal to 72 over 3x plus 7. And remember, as we talked about before, when we have two ratios that are equal to each other, they are called proportions. And proportions we can solve by cross multiplying. So we can then go ahead and do 9 times 3x plus 7 is then equal to 5 times 72. All right, remember, we do the one numerator times the opposite denominator. And now from here, I'm going to draw a line going down my equal sign, just so that way we can remember. that we only have to take the inverse operations when we move to the other side. We're going to simplify both sides of our equation. So 9 times 3x gives me 27x, and 9 times 7 gives me 63. And 5 times 72 is going to be 360. And then from here, I'll go ahead and subtract over 63. So I'll subtract over 63. And I get 27x is then equal to 297. And now we'll divide each side by 27, divide each side by 27, and x is equal to 11. And that would be our final answer for this question number 8, that x is equal to 11. All right, so now for this next question, we had to solve for a variable. So it told us to solve for the variable b. So that means we want to isolate that b all by itself. So remember, when we're doing, I know I haven't been writing this down, but we've done it a lot so far. When we're doing our solving equations, we're actually working PEMDAS and reverse. So we need to do our subtraction, addition, division, multiplication, exponents, and then parentheses. Well, even though you don't see a parentheses here, remember, as I told you before, when it's written in our numerator like that, it is grouped together, and that's what the parentheses does. It groups them together. So that means that this b minus 9 actually is what we would do last. So we would first need to get rid of this division of a because that would come before parentheses. And the way that we get rid of dividing by a is we simply just multiply each side by a. So I will multiply this side by a and multiply this side by a. Well, the a's cancel, and I'm left with b minus 9 is equal to ac, or if you wrote it as ca, I'd still give you credit. And then we're going to add the 9 to both sides, because now that we do just have this b minus 9, we need to isolate the b, and that will give us b is equal to ac plus 9. And that would have been your final answer for that one. All right, so for question number 10, it said to solve and isolate for a variable y. So I wanted to get that all by itself. So that means 5x plus 2y. So I need to get rid of this 5x. And what some of you were having trouble with is you guys were thinking that this was subtraction for some reason. But remember, it's positive 5x. So this is actually being added. Even though it's not written that way, we could rearrange it and say 2y plus 5x is equal to 9. And you can clearly see it's being added there. So if I want to move the 5x, the whole 5x to the other side, I would need to subtract the 5x from both sides. And then I'm left with 2y is equal to negative 5x plus 9. And then from here, we say, okay, we need to isolate that y. So I need to divide it by 2. And everything on the other side needs to be divided by 2 as well. So then we get y is equal to, and you could have left it as negative 5x plus 9 over 2. You could have broke them up into their own fractions. You could have also wrote 9 minus 5x. Any of those will be acceptable, but this would have been your final answer. And as we're learning in this unit, we actually will start to separate those into their own fractions, but you didn't need to do that for this one here. All right, so for question number 13, we need to first translate this. So for part A, we needed to translate it into a mathematical equation. So it says 4 less than. Well, remember, this less than was one of those turnaround words, which meant that it's actually going to be minus 4 at the end. So remember, this 4 less than, it's not 4 minus, it's whatever we had. We're doing 4 less than that, so we need to subtract 4. So 4 less than the quotient. Quotient means division, and remember, when I said after we see quotient, product, any one of those, we replace the word n with the operation. So I know that this n is going to be replaced with the operation. So it's a quotient of twice a number. Well, twice a number means that we're doubling it. So we can say 2n or 2x, whatever you want to say. And since it's a quotient of twice that number, n7, that means that this is being divided by 7. And remember, we were doing 4 less than that, so we had to subtract 4 after we take that quotient, because 4 less than whatever this was is, we know, is going to be equal and 42. So that will be our part A. Our part A would be creating the equation. Part B would be defining our variable. Well, n represents, in this case, just an unknown number. They didn't give us anything specific about it. It's just simply to set a number. So there's nothing really more that we could do with it. And C, we were going to have to solve if you were to do this. Now, you didn't have to solve all of them, but you could have chose this one. So I'll go through and solve it. We have 2n over 7 minus 40, or minus 4 is equal to 42. So now from here, we can go ahead and add 4 to both sides. So now we get 2n over 7 is equal to 46. And then we're going to go ahead and multiply each side by 7 to get rid of that division of 7. So these then cancel. And now I'm left with 2n is equal to, 280 plus 42, which will then be 322. And then our last step that we would have to do is divide each side by 2. And n is then equal to 161. So our answer for n would be n is equal to 161. And if you didn't decide to answer this one, it was fine. You didn't have to answer all of them. You only had to pick 2. All right, let's go ahead and do the last one before our mastery. All right, so for question number 14, for part A, we had to create the equation just like we did before. And it gave us, it said your car needs new brakes. You call a dealership and a local mechanic for prices. And it tells you that the cost of the parts for the dealership is $25, whereas for a local mechanic, the cost for the parts is $45. So no matter what, that isn't cost per parts per hours, it's just how much the parts cost, period. So that value will never change. It will always be 25 and always be 45 if you go to the dealership or the mechanic. And then here it says labor cost per hour. So this is what will change because this is per hour. So if you go to a dealership, they're charging you more per hour, where the local mechanic is a little bit less. So it says write an equation to show when the two dealerships are equal in price. So the first thing is we will solve for, well, how much does it cost for the dealership? Well, we know as soon as we go for them, the parts are going to be $25. So no matter what, it will be $25. And every hour that it takes for them to fix your brakes, it will be 99 times the amount of hours. So we know that the dealership is 25 plus 99H, right? And it says when they are equal in price. So that means that we're just going to create an equation that makes them equal. So that is dealing with the dealership. And then the local mechanic, we know that the cost of the parts is $45. So no matter how many hours they work, we know it's already going to be $45. And then they're charging $89 per hour. So it'll be plus 89H, right? And then from here, we're going to define our variable. Well, H in my case represents the number of labor hours, so the number of hours that they take to fix your brakes. Right? But for those you need to be specific. Someone just said represents unknown numbers. Well, we could be more specific than that in this one because we have more detail. And someone said H represents how long it takes for them to be equal, but that's not necessarily true. In this case, it does. It will show when they're equal, but we can also solve this for other hours when maybe one's greater than other. So we want it to represent where we can use it no matter what scenario we have. In this case, it would be labor hours. And then if you're going to go ahead and solve for this, we will then have 25 plus 99H is equal to 45 plus 89H. We can then go ahead and subtract the 89H from both sides. And now we got 25 plus 10H is equal to 45. And then we can go ahead and subtract 25 from both sides. So we get 10H is equal to 20. Divide each side by 10. And H is then equal to 2. So that means it would take 2 hours for them to be equal in price and cost. All right, so now there's just one more question. That's it for this video. All right, so I wanted to go over this one. So we know that when we were solving this before, that we can create 2 equations. So 2x plus 6 is going to be equal to the positive of the answer that we have, so the 4x. And then we know that we can create another one where 2x plus 6 is also equal to the negative of it. So that means it's equal to negative 4x. So we have 2 different scenarios that we can solve for. And now we're just going to go ahead and solve for both of them. So I'm going to go ahead and subtract 2x from both sides, so this way I can get my x's together. So now I got 2x is equal to 6, divided by 2, and x is then equal to 3. Or I'm going to go ahead and subtract the 2x. So negative 6x is equal to 6, divided by negative 6, or x is equal to negative 1. All right, now, as I said to you before your test, even when the tests were handed out, for your mastery, I said plug them in, check your work. All right, so let's go ahead and check our work. So if x is equal to 3, we have the absolute value of 2 times 3 plus 6. Does this equal to 4 times 3? Well, 2 times 3 is 6, so the absolute value is 6 plus 6. Does this equal to 12? Well, the absolute value of 12 is in fact 12. So yes, they did equal for that one. So we knew that this answer worked. So I'm going to go ahead and highlight this and say, okay, that one worked. So now let's go ahead and do the second one. Let's plug it in here. So now we have the absolute value of 2 times negative 1 plus 6. Does this equal to 4 times negative 1? Well, the absolute value of 2 times negative 1 is negative 2 plus 6. Does this equal to negative 4? Something should already be telling you that this is not going to work. But negative 2 plus 6 is 4. So the absolute value of 4, does this equal to negative 4? Well, the absolute value of 4 is 4, which does not equal to negative 4. So this tells us that this actually does not work. And what this is, and what I wanted you to see is I wanted you to identify, whoa, wait a minute, we got a solution, we plugged it in, It didn't work. We actually will learn in the future that this is called an extraneous solution, which means that algebraically it worked when we actually were solving, but when we plug it back into the context of the question, it doesn't. So this is actually not a solution. So I was just hoping to see that maybe you crossed it out, that maybe you pointed out some way that this doesn't work. But that's what we're looking for that one. All right, and that is it for this video.